Rapid industrial and population growth in the dry and arid Arabian Gulf nation of Saudi Arabia has prompted a substantial need for fresh water. Water desalination makes for an appropriate approach for this vital need. Therefore, the construction of more plants along the east coast is not out of the ordinary. The total production capacity of all desalination plants in the Arabian Gulf countries was estimated at 5.075 million meters cubed of water per day, which represents over 58% of all the world's desalting plants' abilities. Dr. Mohammed Antar, a professor at KFUPM, briefly explains how desalination works.
What we do for desalination is that we try to remove the salt from the water, or precisely remove the water from the salt. This can be done by two ways, either by evaporation and condensation that mimics what's happening in real water cycle, so that water is evaporated from the surface of the ocean, it goes up, it forms clouds, the wind drives the clouds, and then it reaches into a very cold area to make icebergs, or to a warmer area where it turns into rain. The rain falls, fills water tables below the ground, and the remainder is going to go back to the sea. That's the complete cycle. In thermal desalination systems, what happens is that we're trying to imitate that by bringing seawater, heating it, it evaporates, we take the vapor, we condense it, and then we get sweet water or pure water. And then the process is repeated at lower pressures. Why is that? Because when you reduce the pressure, you can generate more vapor. So this is basically the idea. The other type of water desalination systems, which is famous, probably now it's dominating in the whole world except for the Gulf region, is the reverse osmosis, in which you drive the water against hydrophilic semi-permeable membrane. It has pores of a specific size, and if you leave the water and the membrane, sweet water on one side, salty water on the other side, water is going to go through the pores from the sweet water to the salty water, because there's a higher potential here than there, which is the osmotic pressure. If we need to have water from the seawater moving to the other side, which is the target, we have to apply a pressure higher than the osmotic pressure. It drives the water through the membranes, and then you can get sweet water on the other side. This process does not need heat, it only needs mechanical work.
The issue with water desalination is that it results in the discharge of brine, a byproduct that is extremely saline. This brine water is dumped into the Gulf on a daily basis. And the fact that the Gulf is largely enclosed, shallow, and is having high evaporation rates does not help the issue. Conversely, it makes it worse. And as the Gulf increases in salinity, more and more organisms are being affected. For instance, the photosynthesis of plankton is halted by the presence of chlorine in the brine. In addition, anti-scalant additives that are usually flushed along with the brine are very dangerous, for they can cause eutrophication, an increase in algae growth which can cause the water's quality to deteriorate. And as there are environmental risks, there are also financial risks posed by dumping the brine, and Dr. Mohammed Antar explains these risks.
Question, I can tell you that if you are going to work an RO unit, reverse osmosis unit for water desalination in the Mediterranean, the power that you need is about 2.5 kilowatt hour for every 1 cubic meter of the water. If you are going to do it in the Gulf, it will be 4.5 kilowatt hour per cubic meter. Why is that big difference, which is almost twice? It's because of the high salinity of water in the Gulf.
The salinity of the Gulf is increasing each time we desalinate water because of the way we're disposing of the brine, and that is through an outfall into the Gulf. This increase in salinity has resulted in great financial losses and severe damages on the environment. This is why we must act now and try to find solutions for this issue. One solution that can be implemented in Saudi Arabia and other Gulf nations is the chemical conversion of brine by using the modified version of the solvay process. This was proposed by Farid bin Yahya. The diagram shown explains the process. First, you need to know that the water ionizes to OH- and H+. The same goes with the brine, or NaCl aqueous, to Na+ and Cl-. The H+ forms NH4+ with ammonia, which then forms NH4Cl, leaving the sodium to form NaOH, or sodium hydroxide, with the OH-. The NaOH then reacts with CO2 to yield NaHCO3, or sodium bicarbonate, in other words, baking soda. This process aims to produce baking soda. Another product is ammonium chloride, or NH4Cl, which will then be reacted in another reaction with CaO, or calcium oxide, to retrieve the ammonia back. And the reaction also yields calcium chloride. The retrieval of ammonia is very important because it is what makes the whole process cost efficient, along with the fact that CO2 is an abundant resource in Saudi Arabia. The idea behind electrolysis is to provide a current to drive a non-spontaneous reaction. By providing a current to the brine, Cl- would be oxidized to chlorine gas, and H+ would be reduced to form hydrogen gas, leaving the Na+ and OH- to form sodium hydroxide. To sum up, at the end of the process, 3 different compounds are formed: sodium hydroxide, chlorine gas, and hydrogen gas, which are all very expensive products. This is what Dr. Antar had to say about brine electrolysis.
Again, a very good solution, and it is being done in many places in the world. Brine basically is high concentration of sodium chloride and water, so that's the solution. Using the electric current is going to change the chemical composition, and the chemical composition here is going to bring a new chemical compound through this process that we call electrolysis. So it's a large scale process. It results in bringing chlorine, which is a disinfectant, and a purifier in some industrial processes. It can also produce other chemical components, the hydrogen, which is an environmental friendly fuel, and it also produces sodium hydroxide, which is needed as a purifier in many of the food processes. So the answer to your question, yes, and it can be done in a high scale, and it's a very profitable sort of way to get rid of the high concentration of brine.
Numerous other solutions do exist, some of which don't require input energy and work. Selling the brine, for instance, to other countries would prove beneficial, since brine can be converted to multiple useful products. Some countries may be interested in buying the brine. Using the brine as a dust control is especially suitable for Saudi Arabia, since it is an extremely dry and hot region. The brine retrieved from the desalination process, if sprayed properly, can absorb the water and moisture from the air and under the road. This allows the aggregate particles to be binded together, which in turn helps control the dust. After learning about this issue almost 3 years ago, I started to ask myself, what can I do as a citizen to ease the damages done by it? I would like to end the documentary with Dr. Antar's reply to this question.
The answer is conserve water. The rate of water consumption is extremely high. The world standards are 250 liters per person per day. In the Gulf, it's 450. So although we don't have rivers, we don't have sources of pure water, we don't have heavy rains. So water is precious, and actually it is subsidized by the government. The price of water that we buy in the market, this is not the true price. The true price is more than that. But the government is subsidizing it by making the fuel a little bit cheaper, and hence people can produce more water at sort of a moderate rate. In spite of that, we are wasting water for many, many applications that should be conserved. I read once, I'm not sure about that, but the Islamic scholars used to use as much as 10 liters per day. We're talking about world 250. Saudi and the Gulf is 450. So conserving water is the message that everyone should carry and teach it to the surrounding people.